Hi everyone, in this video we're going to learn how to simplify radical expressions. Make sure that you are good with simplifying radicals before you attempt to do this. So our first example here, we have the square root of 50 plus 2 times the square root of 48 minus 4 times the square root of 18 plus 6 times the square root of 243. And we're going to start this by simplifying these radicals. So the first thing I want to do in this question is consider the numbers under the square root sign and look at what is the biggest perfect square that they are divisible by. So starting with 50, the biggest perfect square that it's divisible by is 25, and it's 25 times 2 is equal to 50. Moving to 48, that's going to be 16 times 3. 18 will be 9 times 2. And 243, what that's going to work out to is 81 multiplied by 3. So now we can rewrite this expression subbing in our perfect squares. So instead of root 50, we're going to write root 25 multiplied by the square root of 2. We are adding to that 2 times the root of 48, which is root 16, root 3. Then we are subtracting 4 times root 18. So negative 4 times the square root of 9 times the square root of 2. And then we are adding 6 root 243. So that'll be 6 times the square root of 81 times the square root of 3. The next thing we can do is take the square root of all of our perfect squares. So 25 will just change into a 5. 16 will change into a 4. 9 will change into a 3. And 81 will change into a 9. Let's simplify this even more by multiplying. So the 5 root 2 stays as is. 2 times 4 is 8 root 3. 4 times 3 is 12 root 2. And 6 times 9 will be 54 root 3. Now we can simplify it by combining like terms. So we have 5 root 2 minus 12 root 2. What that will work out to is negative 7 root 2. And we have 8 root 3 plus 54 root 3. And that will work out to 62 root 3. So we're going to add that as well. And that is our final answer there. Let's look at our next question. It's the same thing, same process. So in this question, we're going to start it the same exact way. We're looking at our numbers and figuring out which perfect squares they're divisible by. The biggest perfect square that this will be divisible by is going to be 49, and it's 49 multiplied by 5. 4 root 7, 7 is not divisible by any perfect square, so we don't need to worry about that. 162, what will that one be divisible by? 162 works out to 81 times 2. And then 32 is going to work out to 16 and 2. Let's rewrite the equation, replacing our square roots with the perfect squares. So 245 is the square root of 49 multiplied by the square root of 5. We are adding 4 root 7. Then we're going to subtract 8 square root of 81 square root of 2. And then we're subtracting again 4 times the square root of 16 times the square root of 2. Then we square root our perfect squares, so 49 will give us 7. The 4 root 7 stays the same. 81 will give us a 9. And the 16 will give us a 4. We can simplify by multiplying some of those numbers together. So in terms of the 8 times 9, that will give us a 72 root 2. And the 4 times 4 gives us a 16 root 2. When we add those together, we have negative 72 minus 16. What that will work out to is negative 88 root 2. And that is that question fully simplified. On to our next example. This time we have some variables in here as well. So in this question, we're going to start it the same way. We're going to look at what's under the square root sign. In terms of the root 3, you can't really do anything with it, but the 192a squared, we are going to be able to do something with it. If we look at the 192 and determine what perfect square it's divisible by, 192 is 3 times 64. So that's the one we're going to be using there. A squared is just a perfect square. So remember, the square root of a squared is just going to give you a. Same thing with the square root of 64. That is a perfect square. The square root of 64 is going to turn into 8. So if we look at this equation, it works out to a root 3 plus, instead of writing 192a squared, I'm going to write this as 64a squared. So I'm pulling out all of my perfect squares multiplied by root 3. And then for our last one, we're writing 4 times 8. Let's simplify this a little bit more. So we have a root 3 plus 64a squared can be simplified to 8a root 3. And then 4 times 8 is just equal to 32. In this case, when we are combining like terms, we have an a root 3 and an 8a root 3. So when we add those together, we end up with 9a root 3's, and then minus 32 at the end of that. And that is that question fully simplified. On to our next example here. So this case involves more variables than before. Let's take a look at what we have, though, under our square root sign. So for our first one, we have a squared b. A squared is a perfect square, so we can just pull this out and we can make this equal to a root b. In our second one, we have a 4, and then we have 100b. 100 is also a perfect square. When we square root 100, we get 10, which leaves us with root b under the square root sign. And then in our third term, we have 3 times the square root of 4c squared b. 4 is a perfect square. When I take that out, it turns into a 2. C squared is a perfect square. When I take that out, it turns into a c. And we end up with a root b as well. Let's simplify this by multiplying. So a root b plus 3 root b minus 3 times 2, which is 6, times c root b. Now, if we want to simplify this, one thing we can do is common factor it. Because there's a root b in all three terms, we can just take that out. So taking out the root b, we end up with a from our first term, 40 from our second term, and negative 6c from our third term. And that would be our final answer here. Let's do another one. So in this case, what we're doing is we are expanding this. So we're going to FOIL this through, starting with root 3 multiplied by 27. Remember, when you are multiplying radicals, all you're doing is you're multiplying the numbers under the radical. So we're going 3 times 27, which works out to 81. Then we have root 3 multiplied by root 12. So 3 times 12 will give you a 36, and that's the number that's going to go under the radical. And then in our last term, we have root 3 multiplied by 4 times root 3. And again, you can multiply the numbers under the radical sign. The 4 is just going to stay on the outside, and we get 4 times root 9. These are all perfect squares, so that actually worked out really nicely. The square root of 81 is just going to give you a 9. The square root of 36 is going to give you a 6. And the square root of 9 is going to give you a 3. Simplify this a little bit more. 9 plus 6 is equal to 15, and we are subtracting 12. So our final answer here will be 3. Let's do one more example of this. So in this example, we have two brackets being multiplied by each other, so we have to FOIL this through. We're going to start with root 5 multiplied by 2 root 8. That's going to equal 2 root 40. Then we have root 5 multiplied by negative 6 root 3. So that's going to turn into negative 6 root 15. Then we have negative 2 root 2 times 2 root 8. So that'll be negative 4, the 2 times the 2. And then inside the radical, we have 2 times 8, which is root 16. And finally, we have negative 2 root 2 multiplied by negative 6 root 3. So negative times a negative ends up being a positive 12. And then a 2 times the 3 ends up being root 6. Let's see if we can simplify these. I'm noticing right away that 40 is divisible by 4, which is your perfect square, as well as 10. And 16 is a perfect square. It just works out to 4. So if I simplify this, I'm going to turn it into 2 times root 4 times root 10 minus 6 root 15 minus 4 times 4 plus 12 root 6. And then simplifying it even more, I can turn the root 4 into a 2. And I can multiply the 4 times the 4, giving me a 16. And then finally, let's multiply the 2 times the 2 together to give me 4. And this will be our final answer here.